Hi, Year 12. We're just going to go through introducing this next topic of abnormality, which is the final topic of paper 1. It's got a lot of links with paper 2, in particular the approaches section, and that's why this section on abnormality is relatively small in comparison to the previous topics of social influence, attachment and memory. So it does appear that we'll probably get through this significantly quicker than we have the others, but that's because we already have introduced quite a lot of these ideas and concepts at the start of the course when we were talking about the approaches. So this is what we need to go through in the next few weeks. It's often referred to as psychopathology, so you might see that in some of the textbooks. Most revision guides and textbooks just go with abnormality. It means more or less the same thing, that we're looking at abnormal behaviour and mental illness. We have to start by explaining the definitions of abnormality. Not everybody agrees how abnormal behaviour should be defined and characterised. So we'll look at the 4 conflicting approaches and methods of defining abnormality. Then we have to focus on 3 different types of abnormal behaviour. The first one, phobias, the second, depression, and the third, obsessive compulsive disorder. We have to know the explanation of each, the characteristics that are associated with each, and how each illness would be diagnosed. And then we have to try and explain phobias, depression, and obsessive compulsive disorder from a behavioural, a cognitive, or a biological approach. Now, at the start of the course, we looked at approaches in psychology. In the first few weeks, we broke it down into each individual approach, and we looked at the key individuals. We did it as a timeline, if you remember, starting with psychodynamic and then finishing ultimately with the more modern social learning theory and cognitive psychology. We only need to look at behavioural, cognitive and biological for this approach. We're not going to refer to psychodynamic or humanistic at all, and that is because no questions on paper 1 will relate to psychodynamic or humanistic. If you ever see psychodynamic or humanistic explanations of depression, phobias, or obsessive compulsive disorder, then chances are they're from the old specification. So I'd say for simplicity, just completely ignore those approaches in the context of abnormality. So I said that we're going to start with definitions of abnormality. So this will be for the first 2 weeks. First of all, we need to look at standard deviations. Then we look at deviation from social norms, failure to function adequately, and deviation from ideal mental health. For today's lesson, or today's topic, is standard deviation. You will need a scientific calculator. I would prefer you to use a scientific calculator than your mobile phones or laptop, because then you start to familiarise yourself with the buttons and the functions of your scientific calculator. Remember, you are allowed to take a calculator to all 3 psychology exams, but obviously you can't take your phone or a laptop. So it's far better that you start to familiarise yourself with the buttons and the functions of your calculator rather than using your phone. Once we've done that, we'll look at the deviation from social norms, which is more sociological than the mathematical approach that we're about to look at. And then eventually we'll move on to failure to function adequately and deviation from ideal mental health. These are the only 2 definitions where we actually refer to psychologists. For statistical deviation and deviation from social norms, you don't need to know any names or specific research whatsoever. You just need to be able to outline the approach and identify the strengths and the weaknesses of using that approach to define abnormality. Now, normally we would start abnormality by considering these questions, and ultimately we are going to try and answer these 3 questions by using each one of the definitions that we just identified. So how do we know if somebody is behaving abnormally? So we have to be able to explain using these approaches when somebody would be classified as being abnormal. Now, generally, when we consider abnormal behaviour, we focus more on the people that we are familiar with, such as our friends, our family, our work colleagues, the people that you see on a daily basis. But we also have to consider, how do we identify abnormal behaviour in a stranger? So how might a psychologist, a doctor, a psychiatrist who's never met a patient before in their life be able to say, yes, the behaviour that you're displaying or the characteristics of your behaviour are abnormal and therefore require help and intervention? And we also have to consider at what point does abnormal behavior require intervention, because we are all abnormal. We behave abnormally at different points throughout our life. So at this moment in time, it feels quite abnormal, our behavior compared to what is normal behavior, what behavior we would normally be displaying when we're studying A-level psychology. But at what point do psychiatrists, psychologists and doctors say, now this person needs support and help? And sometimes it might be that doctors, psychiatrists and psychologists decide to intervene on the behalf of the patient. So many individuals might not feel that they need help and support, but in other individuals, doctors, friends, families, they believe, actually, I want you to experience this intervention, this support. So we have to consider these three questions. And to start off with the statistical deviation, this is all based upon mathematics, and that's why you need your calculator. This approach defines abnormal behavior by saying it's simply behavior that deviates from what is normal or usual. Now, the most difficult concept of statistical deviation is how do we define what is normal or usual? And that's where statistics come involved. We can define abnormality by calculating how much behavior or characteristics deviate from what is statistically normal or average. So we effectively can calculate a mean score and an individual participant score, or a person's score, what is often referred to as a Z-score. And if that score deviates significantly from the mean score, the average, the normal score from a population, then we would consider that person to be statistically abnormal. Now, the vast majority of people, 95% of the population or a population within a sample, would fit within 2 standard deviations of a normal or mean average score. These people would consider to be completely normal. It's just a normal spread of scores. However, the people who do not fit in within that 95% will deviate beyond 2 standard deviations away from an average or mean score. Then those individuals should be classified as abnormal. Now, just to explain that in a little bit of context, if we think about IQ scores are relatively well known, that we can calculate a person's IQ score. Let's just imagine that we calculated everybody in the country's IQ scores. We all took the same test and we're all given an individual score that generally ranges between about 65 to 145. We could then use all of those individual participant IQ scores to calculate a mean score for the population, so an average IQ score for Great Britain. And once we have done that, we can calculate a standard deviation, a spread of scores around that average IQ score, and be able to work out which people fit within 2 standard deviations of the mean score and therefore have normal IQ levels, or which people fit within the 5% and fit outside the 2 standard deviations of IQ scores and therefore are completely abnormal. Now, just to put this into a little more visual context, if we have a histogram here that's represented on this graph, we know it's a histogram because all the data is related. There are no significant bars between the data sets. Here on the y-axis, we have frequency, so percentage of people in our population that achieve these scores. So each bar would represent, for instance, on the 100 IQ score, around 2.6 or 2.7% of our population achieving that score. If we calculate the average score, let's just say for argument's sake that the mean score calculated from IQ scores of Great Britain was 100. So the average IQ score in this country is 100. Once we've done that, then we can start to use individual IQ scores to work out where they fit on our distribution. So how close are they to the average score? The further away they are from the average score, the more abnormal they are likely to be. Well, anybody who falls within 68% of the population, so anybody who falls within 1 standard deviation of the mean score, so they range from around 85 to 115 on their IQ scores, are completely normal because they are clustered around that mean score, the average score, IQ score of 100. So they're completely normal individuals. The same applies to the people who fall within 2 standard deviations from that central mean score. So 95% of our population are completely normal. So anybody who has an IQ score that ranges between 70 and 130 are normal. Statistically, they fit within 2 standard deviations of the mean score, so they are considered to be normal. However, it's these individuals that outliers on our distribution score. 5% of the population will fall at least 2 standard deviations away from that average score. So these people are considered to be abnormal. They've either got an abnormally low IQ score that ranges on our chart between 65 and 69, or they've got an abnormally high IQ score, which range from 131 to 145. Because statistically they are exceptionally high or exceptionally low, they therefore are considered to be abnormal according to this definition. This gives us the opportunity just to introduce skewed distributions. So this is how you would describe a distribution. What we've just seen there with IQ scores is a completely normal or symmetrical distribution. And here you can see on this little graph here, it represents what is often referred to as a bell curve. And this is because the mean score, the average score, the modal score, which is the most frequent, so the peak of our frequency, the peak of the graph, and the median score, which is obviously the middle score, are all relatively equal with the distribution. So it's completely normal. We're seeing a nice symmetrical curve. However, that is quite rare when we're considering psychology. What is more common is skewed distributions, and this means it could be positively or negatively skewed. A negatively skewed distribution is when the mean score is lower than the middle score, the median score, or lower than the modal score, the most frequent score. Now, in the exam, you might be asked to describe the type of distribution by just the data. So if they give you individual scores, so the mean score, for argument's sake, is 20, the median score is 25, and the modal score is 27, then we know it's a negatively skewed distribution because the mean score is lower than the median score and the modal score. If they do not give you the individual data scores, they just give you a graph that looks like this, then we just identify the long tail. So here we can see the long tail is before the mode. The mode will always be the peak. The long tail before the mode indicates a negatively skewed distribution. If we flip that image around and we see the modal score, the peak is first before the mean score. So the mean score is effectively higher than the mode score, but lower in its frequency. Then we can see the long tail is after the peak, and therefore it becomes a positively skewed distribution. It effectively means positively skewed. There are outliers, high scores that are pulling the mean score up, or here there are outliers, low scores that are pulling the mean score down, because we know to calculate the mean score, you have to take into consideration all scores in a data set. So exceptional highs, exceptional lows can significantly affect the calculation of the mean score. Now we will look at specific exam questions on distributions when we look at further research methods. I thought it might just be a good opportunity to bring it in now to demonstrate the types of distribution. And also, if you're using the textbook, it also starts to refer to different types of distributions there in the abnormality section. So I didn't want you to read ahead and start to think, oh, we've missed this during the lesson. We generally focus more on this when we look at statistical analysis in further research methods, which will be at the end of year 12 or start of year 13. Here's just an example of a skewed distribution. Here we have this graph representing income in America. So the y-axis represents the frequency, so the number of thousands of people who earn this is their yearly salary, and we have the different ranges of yearly salary down on the x-axis. So we can see here the modal score is the peak. So even though it's not represented on this graph, we know that the mode score is most frequently occurring score, so therefore it must be the peak on a histogram. So the peak here looks to be around maybe $25,000 a year in America. However, if we calculate the average score, the mean score, it's being represented at around around $59,000 a year. Now we know here that we have a positively skewed distribution because the mean score is after the peak modal score. Now, if we think about it in the context of income, we know that some people earn significant amounts of money, so obscene amounts of money every year. If they're included in our calculation of the mean score, then even though there's not a lot of these individuals who are earning $100,000 a year or more, it is being included in our calculation. So the mean score effectively is being pulled up and increased, from the most frequently occurring score. So that's just to demonstrate an example of a positively skewed distribution. However, what I'd like you to have a look at now is an activity which is fictional research by a lecturer called Dr. Beck. What we need to do is effectively 4 different calculations or activities before we can identify whether or not a person is considered to be statistically normal or abnormal. So we're going to calculate the mean score and the median score. When you're writing the mean score, I want you to do it to 3 significant figures. So that's not 3 decimal places, that's 3 significant figures. Once we have the mean score and the median score, we will then use those to display and draw a histogram. When drawing a histogram, remember to label your axes correctly, and the bars should touch. They definitely should touch your histogram, or else you're drawing a bar chart. The examiners could ask you to draw a histogram, so we have to continue to practice drawing those histograms. It's probably more likely that they will ask you to interpret a histogram and what it actually means, rather than actually asking you to draw a histogram. However, we've got to make sure that we're preparing for all eventualities. And once we've done that, we will effectively calculate something which is known as a Z-score, and this will allow us to see where a participant fits within the distribution of scores, and any participant who scores higher than +2 or -2 would be classified statistically as being abnormal. So what I'd like you to do is I would like you to open this Word document. This Word document, the first page just explains the statistical deviations approach to abnormality. It also includes those graphs from that PowerPoint slide, positively skewed, negatively skewed, and symmetrical or normal distributions. You can print that off just for your notes so that you don't have to print off all the slides from the PowerPoint. Here's the scenario. Dr. Beck has noticed strange behaviour among some of his undergraduate students in his lectures. He decides to use the statistical deviation method to identify students who may need help and support. He uses a well-validated and reliable method of measuring their cognitive state, assessing issues such as self-regard and happiness. The test is conducted online and is out of 140, a higher score indicating high levels of happiness and high levels of self-regard. So first of all, calculate the mean score and write your mean score to 3 significant figures. So to do that, you just add up all the individual participant scores, and then you divide by the number of participants that we have present, which is 20. To calculate the median score, put them in numerical order and find the middle value in our data set. Once you've done that, I want you to display your information on a histogram. And to do that, what we need to do is identify class boundaries for our x-axes. Well, Dr. Beck suggests using the class boundaries below. So class boundaries 31 to 40, 41 to 50, 51 to 60, etc. What we need to do is calculate the frequency in which these class boundaries occur. And that way we will know how high to draw each bar, how high on our y-axis we know to draw each bar according to our x-axis. So all we need to do to calculate the frequencies is we look at the individual participant scores, and if it fits within that boundary, then we effectively tally it off. So here, 31 to 40, we look at each individual score and we'll see we only have one participant who scored within that boundary. So we'll put a 1 there, or tally a 1 if you're doing this by hand. The scores 41 to 50, again we will see individually there is only one participant. The scores that range between 51 and 60, well, this time we have 2 because we have 2 participants, who scored 56. So that time the frequency is 2. So you would need to do that for all of the class boundaries. Once we've done that, we could then actually display and draw our histogram. So your histogram will effectively look something similar to this. Now, I haven't drawn this histogram in as much detail as required. I haven't included a title, but I have displayed the three frequencies of the class boundaries that we've just calculated. You would have to do that for all the boundaries. And eventually, you will have a graph that looks similar to the distribution that was in the PowerPoint relating to wealth and income. So that way we can see the frequency of number of students who fall in each class boundary for the test scores out of 140. What I would like you to do then, I would like you to draw your distribution curve onto your histogram and indicate your mean and median score on your histogram. And all you would do to display that is similar to up here. You would just draw lines from your x-axis demonstrating where the most frequently occurring score was, the median score, and the mean score. I'm only asking you to do it for the mean and the median score. The modal score will be indicated whichever bar is highest on your histogram. So remember, you've already calculated your mean and your median score as part of that first activity. Eventually, activity number 4 will ask you to calculate the z-scores for each individual participant. This is where we're really applying the statistical deviation to decide whether or not these people are statistically normal or abnormal according to that test. So this time we're going to use this display of data, this normal distribution, which represents the standard deviation away from the central mean. So what I'd like you to do is just put your mean score in there, whatever you've calculated. Again, we'll use 3 significant figures. And anybody who individually on their test scores falls within 1 standard deviation of the mean score is completely normal. If they fall within 2 standard deviations of the mean score, again, they are completely normal. That would be 95% of our data sample. However, anybody who falls within 3 or beyond 2 standard deviations away from the mean score is therefore considered to be abnormal according to this distribution. Now, to work out where each individual participant falls, we'll just calculate their z-score. And to do that, we need to use the standard deviation, which is calculated at 22.7. This is already done for you. You are not expected to be able to calculate standard deviations in A-level psychology. If they ask you to use standard deviations, it will already be calculated on your behalf, which it is done here because Dr. Beck has done it ready for us to calculate the z-scores. So what we need to do to work out whether or not each individual participant is normal or abnormal according to this approach is we take their individual participant score, so participant scored 100, we subtract the mean score, the average score that you have already calculated from the participant score, and then we divide that number by the standard deviation, which is 22.7. Once we've done that, it will produce the z-score. Now, the z-score should range between -3 and +3. So it could be a negative number, it could be a positive number. Anything that is beyond -2 or +2 is therefore considered to be abnormal. Anything that falls within -2 to +2, so anything that falls less than -2, less than +2, is therefore considered to be statistically normal and fall within the 95% of our population. So you need to do it and calculate every single participant's z-score. Once you've done it for every single participant using that same formula there, we will be able to identify how many participants are considered to be statistically abnormal. There must be somebody who's considered to be statistically abnormal in this data set. You can't have 100% of people being considered to be normal. That wouldn't make any sense at all. There must be at least one of these participants who has a z-score which is beyond 2 standard deviations away. So want you to do is I want you to write the number of the participant who should be considered to be abnormal according to your Z-score calculations. Once we've done that, you can fill in some strengths and weaknesses of the approach. You can use your textbook to do that. Or if we just quickly go back to the PowerPoint, I'm happy to quickly talk about some of these evaluation points. A major strength of using this approach is the definition is completely objective. Because this is numerical, it's not open to interpretation. Statistically, you will have a participant who is normal or abnormal, regardless of what they say, regardless of what any other individuals say about their behavior. We can calculate this statistical deviation for any behavior or characteristic in which we can get a quantifiable or numerical number, and therefore every single person could be calculated as being normal or abnormal. It's not open to interpretation, unlike the other approaches which we haven't covered just yet. However, one major weakness, this approach, when using statistical analysis, will assume that all abnormalities are negative and therefore require intervention. If we think about the example of IQ scores, individuals with low IQ scores statistically might need intervention, so they might need support. So if we use the context of education, these might be individual students who might need a little bit more support when completing their work. However, the other end of the scale is those individuals with exceptionally high IQ scores that might not require any intervention whatsoever. So statistically, they're considered to be abnormal, but it's a positive abnormality which requires no intervention. This approach doesn't consider the fact that some statistical deviations are actually positive and not negative and are a good thing that require no intervention whatsoever. Number 3, the vast majority of mental illnesses are unknown, and we don't actually know about them until a person actually asks for help or somebody starts to observe a person struggling and therefore suggest intervention or support from doctors and psychiatrists. If we use the example of depression, a lot of people hide the symptoms of depression, so they might not actually display and show the characteristics of their mental illness. If we do not know about these behaviours, then they can't contribute to the statistical analysis. So we can only calculate a mean score and average score from the data that we have present. So if somebody is displaying an illness or not displaying the illness, so they're hiding the symptoms and the characteristics of their illness, then it's impossible for us to calculate an average score that is valid. Without a valid mean score and average score, any other analysis using that mean score is also invalid. So unless we actually know and can calculate every single person in a data set, this approach is completely invalid and is effectively useless. We also have to consider about those people who fit within 2 standard deviations, because this approach suggests that if you fall within 2 standard deviations around that central mean, then no intervention or support is required because you are completely normal. If you have a person who is suffering from a mental illness but fits within those standard deviations, then they still might need help. However, this approach would say that they're completely normal, therefore we shouldn't help them. And that could be extremely detrimental. Effectively, what we should do, if a person identifies themselves as needing help, regardless of whether or not the behaviour is statistically normal or abnormal, they should receive that help. If we adopt this approach, those people who ask for help but are statistically normal wouldn't receive the help that is that they should be entitled to or that they should receive. So this approach could effectively have a significant number of the population not receiving any help whatsoever because statistically they would be classified as normal, despite the fact that they might actually be asking for help and benefit from any help that could be provided. So the next topic that we're about to look at is deviation from social norms. So we won't need a calculator at all for that, which I imagine that most of you will find a relief. Once we've gone through all the approaches, these evaluations will become a little more clear. So once we've introduced all 4 approaches, we'll go back and evaluate each individual one, and we'll have a look at a potential exam question that could be set on the evaluation part of defining abnormality. So don't worry too much about the evaluation part just yet. If you're really struggling with any of the calculations, check your textbook first, including the research methods section, which has a lot of information about distributions, histograms, and standard deviation. If then you're still struggling, by all means, just email me asking me for help, and I will try my best to respond as quick as I can to any emails. How do you stop the screen recording?